Welcome to the human ear, window to the amazing world of sound. Ears are responsible for hearing and perception of sound. Hearing is possible through a complex process that involves the ear's ability to detect and interpret sound waves. We can explore the incredible features of human ear and how it allows us to hear the world around us. The human ear has three main parts: the outer ear, the middle ear, and the inner ear. Outer ear. This includes the visible part called pinna, auditory canal, and tympanum or eardrum. Its function is to collect sound waves and direct them towards the middle ear. Middle ear. It contains three tiny bones: malleus, incus, and stapes. These three bones are collectively called ear ossicles. When sound waves reach the eardrum, these bones amplify and transmit the vibrations to the inner ear. Middle ear also contains eustachian tube. Eustachian tube, also known as auditory tube, is a narrow passage that connects the middle ear to the pharynx, situated behind our throat. It helps to maintain proper air pressure inside the middle ear. It is essential for the normal hearing and preventing damage to the eardrum. Inner ear. The inner ear is comprised of cochlea, three semicircular canals, and vestibule. Cochlea is a spiral-shaped structure filled with fluid and hair cells. These hair cells in the cochlea convert the amplified vibrations into electrical signals that the auditory nerve carries to the brain for interpretation. Semicircular canals and vestibule helps in maintaining the body balance. Functioning of outer ear. The primary function of the outer ear is to collect sound waves and direct them into the auditory canal towards tympanum or eardrum. Shape of pinna helps to capture the sound waves from different angles, helping us to determine the direction from which the sound is coming. When the sound waves reach the tympanum, tympanum will vibrate in resonance with the sound waves. This amplifies the sound waves and transmit them to the middle ear. The vibrations of the eardrum are then transferred to the ossicles in the middle ear. The ossicles amplify and relay the vibrations from the eardrum to the oval window. While transmitting, bonds in the ossicles amplify these sound vibrations. Normally, it amplifies up to 20 times higher than what they receive in the malleus. The chain of ossicles, malleus, incus, and stapes acts like a lever system, which allows for efficient transmission of sound energy from the relatively large tympanum to the smaller oval window. This amplification is necessary because the inner ear requires a higher intensity of sound to function properly. The vibrations from the oval window causes ripples in the perilymph of the scalar vestibule. These vibrations travel through the scalar vestibule and will reach to the scalar media or cochlear duct and causes ripples in endolymph within the cochlear duct. The movement of the endolymph causes the basilar membrane to move, and this will cause the movement of hair cells in the basilar membrane. And stereocilia, which are situated on top of the hair cells, are bent against the tectorial membrane, and this will generate electrical signals corresponding to that vibrations. Auditory nerves will carry these electrical signals generated by the hair cells and transmit to the auditory processing centers in the brain, where these signals are interpreted as sounds.